successfully installed at this point? Nice. I'm slowly seeing hands pop. Yes. Okay. Sweet. Well, just so that we don't use all of our time like troubleshooting, I'm actually going to start getting going here. Yeah. Before we start, if any of you guys are still having problems, just raise your hand and we'll come by and help. Yeah. Where are we? Just to get started officially, like Edwin said, if you have a problem still, raise your hand. One of the helpers will kind of come around and help you debug it. If you just got here, these are important links to look at. Sign in at ubacm.org/meeting. All of the stuff that we'll go over is at tinyurl.com/ubcoolworkshop. And if you're in 115 and you need credit, see Angus, who is back there with the striped hoodie and the Coca-Cola hat on. He is Angus.
No. Yes, that's the one.
Yes. It's the second command, Angus. Yeah. Okay. Do you kind of want to like slide through this as I do it?
Are you gonna?
I'm not gonna read word for word. Yeah.
Okay. Because I mean, this will go by very quickly.
Yeah.
I would just talk a little bit about it.
Okay. Okay. Hey guys. Yeah. If you need help trying to still do stuff, you can like talk it out with someone beside you. But if you can be quiet, that like for the most part, other than that, that'd be awesome. Yeah. You can kind of jump between them and stuff. So keep this guy up because I don't really need it. Again, go to these links if you need them. But so welcome to the ACM and Scientista workshop series on getting a web application going. It's going to be a little chaotic here until we get some of the tools like figured out for some of the people. So I apologize. Am I loud enough? Can like everyone hear me? I'm usually a loud person. So sweet. Okay, sweet. I get hands up in the back. So my name is Dan. I am Vice President of ACM right now. Rachel, do you want to introduce yourself?
Yeah, I'm Rachel. I'm the events chair for Scientista.
And Valencia is walking somewhere around. Yeah, do you just want to stand up and like say your name? Yeah. We're going to be giving this presentation today. So like we said, the first week, just to kind of give you a roadmap, first week is going to be databases. That's what we're covering today with MySQL. Second week is going to be APIs and kind of like the back end of things. I believe we're using Flask for that, just to kind of get a nice introduction of how to set up a web application. And the third week will be front end. So that kind of gives you a nice roadmap of where we're going. Was that a question or help? Yes.
Do we need to use Python class?
Yes. But we're going to give those requirements within the next like 2 days after this, just so you can kind of get that stuff set up. Yeah, we will push out like requirements that you need like probably a couple days before the workshop starts, so that you can kind of get stuff downloaded and figure it out so that we can avoid some of this mess. But from there, let's go into day one, which is databases. So what is a database? I guess well, first of all, here. Where are we? A database, coming straight from tutorials point, because it was the best definition that I found. A database is a separate application that stores a collection of data. And it just has an API that your applications can hit so that it can securely and safely connect. But really, you can just think of it like a place to store all of your data. If you know computers at all, or even just barely, you know that your computer has the hard drive and it has the RAM. Your hard drive is really good at storing data for a long period of time without losing it, but it's really, really slow. Your RAM is really fast and can do a lot of computations really fast, but as soon as you turn off your computer, you lose all of that data. So some smart people in the world, like database engineers, wrote this software and different kinds of software that kind of connects those two together to let you have persistent data that doesn't just like delete itself and destroy itself, but also lets your web applications be like super fast and load data super fast. So when you go onto like Facebook, Twitter, MySpace, if anyone uses that, it's a dead company at this point. Really, whatever website you go on, all of that data is stored in a database somewhere. I'm not going to stand right in front of this. So even, and I have like this little meme right here, even those Instagram stories, Snapchat stories coming up 2017, your Excel stories, all of that is held in a database. Somewhere in California, or actually for here it'd be Toronto for most companies, somewhere in their data center, all of your pictures and all that stuff is stored just on a server somewhere. And what happens is when you make like a request to Facebook.com, it says, okay, who am I looking for? I'm looking for Dan. Find all of Dan's status updates and bring all of those back and load them on his page. So all of that, where that data comes from, is the database. And it's actually a huge field to get into to figure out how to build these things fast, how to build them scalable so that they can hold like they can handle like millions of users per second if you're like on Facebook size. There's actually some really cool algorithms and classes that you can take like at UB and elsewhere if you want to get more advanced into it, but we're just going to kind of touch on like the top level. So pretty much breaking it down, a database is just a type of software that lets you store information easily in a organized fashion. Is anyone confused by anything that I've said thus far? And if you are, don't be afraid to raise your hand because I guarantee more people are going to have questions than just you. Do we all kind of get what the concept of a database is? Sweet. It's just a way of storing data. Okay. I'm seeing, sweet, that's awesome. So I guess the types of databases, yeah, thank you. I'm kind of gonna like scroll down, so you can just kind of follow along, but I'll kind of jump around as well. You can go up to like this one, right there. So there's different kinds of databases that you can use, and based on what your application is, determines which one you're gonna use. So it's like a famous battle in like database theory, SQL versus NoSQL. Also, yeah, it's pronounced SQL, it's not SQL. That is my personal preference. But so SQL versus NoSQL. I'm on the side of SQL. Angus is usually on the side of NoSQL, so we fight about it a lot.
That's not an argument if it's better.
Hey,
No, that doesn't work like that. You shut
yeah, exactly. See, this is how these things happen. This is how change happens because people fight in the CS community. So first, what SQL is the type. Yeah, let me rephrase that. Let me start over. So MySQL, the type that we're using, is in SQL, obviously, because it says MySQL. But there's different databases other than MySQL, such as Postgres, SQLite, that all are in SQL and have pretty similar structure to them. SQL just means that it's a relational database that works in tables. So everything is in a table, so think of it like an Excel file. I have my columns of, let's say that we have like a user application, and you can write like blog posts. So for my users, actually, can you bring that down a little, Rachel, so I can like point to it for users? Other way, there we go. So for each user, we're going to have like a unique ID to kind of like identify them in the database with. We're going to have a username. We're going to have a password. Yes, I'm a Bieber fan. And some email associated with them. So when you like log in on like a website or something like Facebook or whatever, they store your information like this. I mean, obviously this is encrypted like 8 times over so that people can't just hack your password. But that's something that we are not going to get into today, just because that's a whole different subset of computer security. But it's similar to this where it's columns, and each column represents like some certain data attribute, and then each row is a different entry. So one user is danced, because that's my username, whatever. The second row is Valerie, and the third row is Rachel. And so this way, as you keep adding on users, you just build this table. And this is one of like the fundamental things of SQL, is everything is table-based, which is good in some regards, but bad in others. So for good regard is, if I have tables, if I have like different things in my database, like let's say blog posts that are connected with users, they can stay independent of each other, but still be connected in some way. And SQL lets you do that pretty well. So let's say I have like a blog post of the Justin Bieber fan club. This is just, imagine like some blog post text being here. I just didn't want to write all that out and take that space up. How SQL works is we actually connect that back up to a user ID or like whatever other model. I guess I should say that first is that in SQL, a lot of this stuff, table and model are kind of interchangeable. They're both like the type of thing you're trying to represent in data. So for this blog post model, it has a user ID connected to 1. So then you know that it was written by myself, ds@gmail.com. For, let's see, Wi-Fi pets are the next big thing. That was written by Valencia because this user ID links back to her name. So if you want to like scroll down a little bit to the cool chart. Yeah, that dude. So that way, I mean, this is obviously like a very basic example, but then you can start to build like almost these tree-like structures of data flow of saying, hey, this is the parent of this object, and then this is the parent of this, and like this is the child of this object. And it kind of lets you structure in a very relational way, while also keeping all of these independent. It's nice because it's kind of faster lookup for these independent things, but it's also slow because, or it's fast if you're trying to keep the two more independent. But if I'm trying to say, hey, grab all of Dan's posts, it might be a little slow unless you've indexed it really well to get all of the posts, because then it has to search through the whole post table just to see which ones are connected to me. So that's kind of like a pro and con of SQL. We will jump down to NoSQL. So NoSQL is exactly what it says. It contains NoSQL. Everything is key value storage. The better, I mean, most people that might confuse you, but just think of it as most of them actually save as JSON. So if you know like JSON, and I know like the 115 people are doing JSON right now, databases such as Mongo store everything as JSON. It's all key value. So instead of looking up like unique IDs and searching through like columns, now I'm just saying, hey, go to the users and just search based on like username is Dan, and just pull that one, and it'll pull out this JSON object. So it works like that. It's faster in regards if I have like a model or like a child, like the blog post, that is extremely dependent on the parent. So I guess it might be better in this situation because the blog post will probably never stand on its own. I mean, if I have like top blogs, it might. So then you can kind of make those like decisions of how you're setting it up. Is that a question about this or a question about setting it up? Okay, sweet. Do you want to?
Windows or Windows?
Mac or Windows? Sweet, so they can help you with that. So everything in NoSQL is key value. It says, hey, I want this key, and it'll return me this value. So it's a totally different, no tables. The other upside / downside, depending on how you look at this and what developers you're working with, it does not have the organization of SQL, where SQL says, hey, I have these columns and they must be filled. NoSQL just says, hey, if I have a user that has these 3 fields but no other user has them, I can just kind of slap those on to that user. So I can kind of play around with like what different values everything has. That's good because you have flexibility, but that's also bad. Like if you're expecting a value that's not there, you might run into some issues. So you kind of got to do a couple checks there. So this is kind of an example of the same data as I showed you above, just in NoSQL. Same 3 user blocks, and then inside of those user blocks we have their posts. So yeah, so their posts are now dependent of their parents. Does that confuse anyone, and does that kind of make sense to everyone, or am I just losing everyone? Sweet, sweet. Okay, awesome. This was a cool kind of chart that I found of a lot of the times when you want to choose like SQL or NoSQL. If you're doing web applications and you have more relational data, you probably want to go with SQL. NoSQL is really good with key value storing, like I said, and storing documents. So if you share like a document on Facebook or something, usually it gets saved in base 64 key values NoSQL storage. And like I said here, it's more flexible. Like where in a relational database such as SQL, you need every column filled and like every entry is exactly the same. In NoSQL, you can kind of play around with them and say, hey, this user is going to have their birthday attached. This user is not, because no one cares about their birthday, whatever. However you want to set that stuff up, you have that flexibility. So does anyone have questions about databases, like in general, what they are, the differences between SQL or NoSQL, why apparently I'm a Justin Bieber fan now, or anything? Before we kind of jump into the playing with MySQL portion. Yes?
Why are we using SQL instead of NoSQL?
Because it's web dev, and because most of the time in web development, if you're doing like user-based stuff, you'll probably use SQL databases. And most companies already have SQL databases set up that you'll like plug into. Yes?
Also, there's a thing called the anti-SQL standard that the majority of companies out there follow when they create any sort of web infrastructure for their applications. So a good 90% of the companies out there will have a SQL standard. NoSQL is still an emerging thing, and not a whole lot of people find it to be stable enough for large scale use yet.
That is actually a good point that I was actually going to bring up if you didn't bring it up. NoSQL has only gained traction the past couple of years. Ever since like, I don't know, the 80s, I'd probably say, SQL has been like the de facto database type. But then with the emergence of like JSON growing and stuff like that, that's when NoSQL kind of jumped on this like community, and big companies like Facebook and Twitter started pushing it a little bit more. So their stuff is kind of set up like, hey, most of our stuff's in SQL, but we have like document storage in NoSQL. So why we're doing it in SQL is because chances are you're going to have to know SQL if you're in CS, but you might not have to know NoSQL. Like I've never worked on a project that used NoSQL for a large scale application, but I've worked on a ton that use SQL, if that makes sense. It's a bigger community, and it's like a bigger thing that you'll have to know. Does it make sense? Sweet. All right. And
Can I
do
jump in the corner?
I can either do this part, or if you want to do it.
You can go ahead and get started.
Oh, okay. Sweet.
Yeah, she's gonna leave soon.
Oh, okay. So I'm going to make this super quick. So now we're actually going to get down to creating our application that we're going to do for the next couple weeks. We're going to do a like to-do list app where it's going to have users, and it's going to have like, hey, Dan's user has to take out the trash, has to get groceries, and a couple other things. So that's kind of where we're going with this workshop, is a nice little to-do list app. If that's cool with you guys. So pretty much talking about databases, you just want to scroll down and show the nice little thing that so we're going to use SQL, like I said, so everything's going to be table-based. So I made this nice little thing that you can kind of read around all the extra information that I have if you want. But we're going to have two major tables. We're going to have the user table and the task table. So a user is just going to have an ID that like MySQL and these databases need to have to kind of like uniquely identify that user. And then a username that will kind of recognize the user by. And then we'll, in the test table, we also have the unique ID. What the PK stands for is that stands for the primary key. In a SQL database, each table, one column has to be the primary key, which says, hey, this is my fastest lookup, which is usually like a numeric ID of like, hey, the first user who signs up will have an ID of 1, the second user will have an ID of 2, and then you can like quickly look up and reference those models by their ID. So we'll also have the task, which is just some text field. We'll have created by, which will point back to the user ID, so that we can kind of create that tree-based structure that we had. And then we'll also have the status, which I'm assuming is like completed, not completed, stuff like that. So with
We can jump into it.
yeah, you can jump in. So with that, I leave it to them.
All right, guys. So I'm more familiar with the Mac, and she's more familiar with the Windows, so we'll kind of go back and forth here. But if you're on the Mac, to start MySQL, you can run, and this is all written right in the README, but you can run MySQL-U root. You may or may not need the P for the password.
If you set up with the password, then you need the password. If you haven't, then you don't.
And if you do, you can change your password using this command, alter user, and this is right in your thing. If you don't need to worry about the password, you don't need to worry about it.
You can just close out of Adam, I think.
All right, it's fine, I know. All right, so the first thing we're going to do is actually create the database. And so MySQL is case insensitive, but I'm going to put it in capitals to just show you what's a keyword. So to create it, we're going to do create database, and then I'm going to name it to do, and always end with a semicolon. And then to see if it's created, we can type show databases, and you should see to do there. So what about Windows? It's all GUI in Windows.
Yeah, Windows, you can basically just scroll down a little bit on the README, and it's pretty self-explanatory. So you can follow along as Rachel's talking, but just kind of go off these images.
And if you need help, just raise your hand.
Yeah,
Yeah, that's fine.
but they're very parallel, just different ways to get to the same place.
So now that we've created this to-do database, we can kind of enter it by typing use, and then the database we want to enter. So to-do, and now you'll see our database has changed to to-do. So like Dan said, we're going to create a task table. So am I going too fast, or is these are just, are we good? Okay. So we're going to create table. We're going to name it tasks. And then I'm going to do this parenthesis. And then this is creating like the column. So our first column is called ID. And then next comes the types. So it's going to be an int, unsigned, not null, and it's going to auto increment on its own. So it'll just go up on its own. You don't need to enter anything there. Then we'll comma for the next column header, which is going to be the task. And that is just of type text, because we're just going to type text there. Our next column header is created by, which is going to be an int, because this is going to be the user ID. And it's unsigned, and it cannot be null. And then we have the status of it, which is a text. And we also have the primary key, which is what's uniquely identifies a record in this table, and that's going to be our ID, because that can only be unique and it cannot be null. And then we can end it with the parenthesis and the semicolon. So hopefully I did this right. And I think I did. And then to show this table, I believe we can do describe tasks. And you'll see that we have this all set up. Make it bigger?
Yeah.
Okay. So there's tasks. Is everyone good with tasks?
Yeah. Yeah.
All right, so I'll give a couple seconds.
If you, give them, if you have Windows and are confused, Mac or Windows? Okay, sweet. I can have your Mac. Boom.
So, Tommy? In the back? Okay, just checking.
What you were doing is you had dash so the dash U says log in with this user, and then group is the user. Does that make sense? All right. Yes. Yes. Who? You? Windows? I am not. Yeah, I don't know anything about the Windows side of it. What's up? All of this stuff is online at that link, so you can just pull it up whenever. That's why I tried to make it. Also, that like document obviously has a lot more stuff that I'm not talking about, so like you can just read more about it. How are we doing? Good? Good. I don't know why, but like whenever I do presentations, my like backup thing to do is I'm just like if I don't know what to do, then I switch to that. Who is still having trouble and or does not have this database? Did you already do the users?
No.
Oh, okay.
So I
Not at what we're looking at right now.
mean, it's
Mac or Windows? Or Linux? Windows? Okay. You will have to talk to Valencia, who is over there. He's on Windows and needs help. If you scroll down a little bit more in the thing, I think she like documented a lot of it. So, sweet. I think you're good in a second. Yeah.
All right, so I'm gonna move on to the users table. It's shorter, it's not bad. So again, we're gonna do create table, and we're gonna name it users. Parenthesis to start our column headers. Our first one's gonna be the ID. Usually tables always have an ID. That's unsigned, not null, and auto increments. And then it has the username who completed the task, and that's text. And also has the primary key, which is, this is also, tables always have this also, and it's going to be the ID. And then end it. So now we can describe, I'm just going to describe users to show it, and then we should have that.
Yeah. Also, if you do show tables, I think it shows.
Yeah,
all
it should
the-
show them too, yeah.
Sweet. It shows
To
everything.
check that you have both the tables, you can type show tables.
Let's see, you have.
Yeah, just try to make it exactly. Yeah, so. Yeah, so task, that's the name of the header, and then text, you just type, and then just comma, and then create file. And then that is the end. Never forget the comma at the end of the. Yep. Does anyone with math need help? Good? Simple?
See what it says and then just hit next whenever it's
And I I know that that's like annoying, but we have all this stuff online, so if you miss anything, then you can just like look at it. And we try to document everything as well as possible. So. We have it? Are we good?
My computer. No, it's bad.
That's okay. Tell me, man, if you're CS now, dual boot. Dual boot or just switch to Linux. Does Windows? That was good.
I want to get a Mac on this.
Linux runs better on old hardware too. Yeah. Because it has less dependencies. So
You just run it on a virtual machine. You just
on an older, no, I'd say just dual boot. It's nicer. Personal preference. Get a Mac if you
haven't let
can.
me wrong yet.
Yeah, a Mac is the best of both worlds because it's the prettiness of Windows with the usability of Linux. But if you're like having non-Mac, just dual boot. Then you still have Windows, but you also have Linux.
All right, is everyone good? All right, so now that we have our two tables, we can show you how to insert into these tables, select things from these tables, and delete. So first, to insert, the command is insert, makes sense, into the table name that you want. So I'll do the example that's in the README. So users, in parentheses, enter the column name that you want to enter, which is username, and then the value that you want to enter, which is my name. How can I show that? I'll select. All right, so once you've insert, and in order to see what's in your table, you can do select asterisk, which means all, so it'll select every single column header from the table, and then from users. And this is what our table currently looks like, or at least mine does. So that was inserting. So I could insert another one. And then select all from users. And now it has Dan's name also. So instead of selecting all, we can also select a specific a specific column header from the table. So instead of selecting all, I can just show the username. So select username from users. So now it just shows Rachel and Dan. I can also just select my name by doing the where clause, which is where, and then I could say where username is equal to Rachel. There you go. So that's some selecting. Not sure how to insert into Windows. How about you, Valencia? It's like in the GUI. Right here.
Wendy, can you take over? Can you take over?
She's leaving for work.
So inserting into Windows, you can do the same way as Rachel did on Mac or Linux. You could type in, so you can create a new query by going to, I believe, what is it, File, New Query, or you just do Control-T, and that will open up a new query, and you could just type the same stuff. So insert into
So
users.
you can use the code in my workbench too.
Or you could just, if you run select all from users, you'll see your table come up, and you could literally just right-click on username and then type in that stuff on your own. And if you want, and then to execute, you can just do Control-Shift-Enter, and that will execute your query. And if you want to filter or update or delete, just run the exact same commands as we saw
over here. Cool.
Yeah, that's fine. I'm gonna turn Do Not Disturb mode on. Wait, it's on.
Oh god.
I don't really care.
Oh, you didn't do deleting.
No, I did delete.
Oh, okay.
Yeah. Do you want to go over?
Just the last command, I guess. I did.
Did
that
you do
one,
that?
yeah.
Okay.
So what's the command to run a query on Windows? Because it's not control T.
Oh.
What is it? So you hit the I.
Go file.
No, wait, Angus. Angus, you hit that little dude.
Oh, when you're trying to set up, what is it? Why? Oh, did this come up in my SQL with it? Oh, to even install it? Let me get, I'll have to get Wendy over. Because I'm not sure. Wendy, can you come here next? Thanks. She'll figure it over. I'm not sure about the code. Not bad. Yeah, you are. Alright, so I'll just show you guys delete. It's the last one we're going to show you. So how to delete something from a table. So let me just see what's in my table. So I want to delete Dan. I really want to delete Dan. So we're going to do delete from users where username is equal to Dan. Okay, now let's see. It's just me. That's the way it's supposed to be. So yeah, you guys can kind of play around with this, inserting into the different tables, selecting and whatnot.
The only thing I did was the creating task off the user.
Oh, I don't know that.
Okay. Let's see if I can do it. So we've kind of showed you how to like add and remove from users. Try and create like a task if you're really daring. We can go over that in like 5-10 minutes. That'll be like the last thing that we do, but yeah. We only have Max at this point. I might have Valencia do like a screenshot, or not screenshot, but like a screen recording, and then post it to the README file.
Does anyone need help on math? Yeah.
Whenever we write like describe task or insert into, will we always just capitalize that?
No, so it's case insensitive.
Okay.
But I was just using capitals. Often they do use capitals, and just to show you what's a keyword and what's not. But you can write it lowercase.
My SQL is the only one that's case insensitive. If you like switch over like something like Postgres, all the commands are the same, but they have to be capitalized. So it's just better to get in the habit of capitalizing, and then that way you separate between what's like reserved and what's just you typing in. So status would be so let's try this. Create by is 1.
So me?
Yeah.
Well, you're the only user now.
Definitely not completed.
Not completed.
So if you want to do something that has more than one column, like a text, like how we had before, you just extend it. So you have the task created by and status, and then you just insert those 3 columns with what you want. Yeah, sweet. So next week with the API, we'll actually show you like how to connect, how to do this through codes that, hey, I can see that this is 1, which means it's Rachel, and how to kind of connect those 2 together more than just through an integer. But for an introduction to databases, I feel like this is solid. Yeah, what's up? You can use words.
What's up? Yeah, no, yeah, that's always going to be there. Yep. Wait, that's URL is good, right? Like, how would you do that?
Yeah, are there any like last minute questions or anything, or I think we're at like yeah.
Like if you're selecting specific entity, why would you
Again, and this is why we use MySQL. MySQL doesn't care. Postgres does care. Other database like software do care. MySQL does not. Single quotes is usually like what Postgres wraps values in. So usually you use single quotes. See you guys next week. Unless you have questions or want to talk to us.